All righty, I've got 5:41 Central Time here, so we're going to go ahead and get started. And I'm going to go ahead and share my screen. There's that. And yay, it didn't keep everything. Okay. So just to let people know, I am watching chat um, while the session is going. So if you have questions, please feel free to put those in chat. And I will definitely stick around after the session is over to answer any session or any questions related to the session. My name is Tony Foster, AKA the Wonder Nerd. I'm a principal technical marketing engineer at Dell Technologies, working in the integrated solutions group. I'm also a VMware vExpert and on NVIDIA's NGCA or Virtual GPU Advisory Council. So with that, hopefully you're all here to hear me talk nerdy, take your breath away with some cool things you can do coding with VMs and vGPUs. If not, you may want to go find the session you were actually looking for. That said, let's get into the required disclaimer. I think everybody's tired of seeing that at this point, but have to show it anyway. So anything I say may or may not be true. Quick overview of what we're doing today. We're going to cram a lot of code and a lot of fun stuff into this 30-minute time slot. We're going to start by looking at what vGPUs are for those who aren't familiar with them, some of the requirements around that, look at the mob, and then we're actually going to do a lot of coding. And we're going to do a lot of coding in a really short time. So hold on to your hats. And then we'll talk about where you can take this next, where you can find resources, and then I'm going to open it up for questions. So let's start with what a vGPU is for those who may not be familiar with it. I'm guessing most everybody knows what a GPU is. It's a PCI card typically that you stick inside your server. And you can see with CPU virtualization only, which I think everybody's familiar with, that over on the left-hand side. You've got a server, a hypervisor, your apps and VMs. And this is actually a slide that NVIDIA likes to use that I went and grabbed because it explains it so well. On the right-hand side, you'll see one with a GPU in it. So you have the server. It now has a GPU, a PCI-based card typically. The hypervisor is still there, and that's passed. That physical GPU is passed up into the virtualization layer with what most people commonly know as a VIB. And that's basically the driver at the virtualization layer, passes that up, and we can slice those physical GPUs into subparts. So we can share those out with different virtual machines. So we can share part of a physical GPU or the whole GPU with a virtual machine, or a GPU with several virtual machines. And that goes up the stack and is presented to VMs. And normally people assume that case. Nowadays, you can do AI. In fact, you've probably been hearing a lot of stuff about AI at VMworld this year. And that's something that vGPUs really shine when you start looking at AI tasks. Oh, yay. Okay, so give me just one moment. If audio is cutting out, I know what's doing that. I'm going to stop my video for just a second while I correct a video setting here. At least I think I will. There, and none. There we go. That should take care of it. So now you get to see me in my natural environment. Sorry, code team, that I wasn't able to keep the background. Okay. So with an explanation about what vGPUs are, let's talk about some of the requirements to do all of this. Obviously, we're programming in Python, so you're going to need Python. And you're also going to need a vSphere environment with at least one ESXi host that has a GPU in it. And the one I'm using today is an NVIDIA P4 GPU. If you want to do this in your home lab, you can pick them up on eBay. I think they're running around $400 right now on eBay. So if you want a P4, you can go get one of those. T4s go up, and the Ampere series, the A series, goes up even higher. So just to give you an idea on that, we'll be using the managed object browser from our vCenter environment, and we'll talk about that more here in a moment. You'll also need the pyVmomi and pyVim modules installed. Those are easy to install with pip command. And then you're going to need some sort of editor, text editor, or an IDE, your choice. I'm a horrible person. I will bounce between text editors and IDEs all day long. Today I'm using Visual Studio just because it's a little bit easier for me to bounce back and forth with code samples. So managed object browser, hopefully, yes, Notepad++ is a great one. I actually use that all the time. Hopefully folks are familiar with the managed object browser. This is a cheat sheet for where you find GPU entries inside of the mob. And when I say mob or managed object browser, it's obviously not the mafia. So don't forget about it. So managed object browser is your best friend when it comes to doing things with GPUs. You'll be able to get this in the slide deck off my website or off the code site here after the session's over. So with that, it's lab time. We're gonna go through and we're gonna start. I'm gonna assume that folks may not have experience even establishing a connection with pyVmomi. And we'll start there real quick and then go through, get a GPU or get the GPUs in a host, get the vGPU profiles available from that host, get the VMs with vGPUs, add a vGPU to a VM, and remove a vGPU. And then we're going to tie all of that together and actually create a VM with a vGPU in it. And we'll link all of these things to that final process so that you understand why we're going through all of these. And yes, the presentation is available on wondernerd.net along with all the code snippets. And the last bit I'll tell you is if you go to github.com/wondernerd, in my VMworld 21 project, you will find all of the code right there for you to download. So yes, you will need additional licenses for that. Thank you for reminding me, Graham. I may have mentioned this before. It was right around the time I was having audio problems. Using a vGPU, you do have to use a driver from NVIDIA, and that is a special driver. You can't just go out and grab the latest NVIDIA driver and load that into a VM. It will cause your VM to fail and fail miserably. You'll then have to pull it out through a SSH session into it and start all over again. And you can get sample or trial licenses for NVIDIA's vGPU technology from their site. I believe there's 60-day eval licenses. They might be 90-day eval licenses currently. I can't remember what they are. So with that, All the code samples, like I said, are in the slide presentation that you can pull down. I'm going to go ahead and hop over to my lab environment. Oh, went too far. And we're going to start coding. So just slide this window out of the way. Here on the left, hopefully you can see my vSphere environment. We're playing in my Horizon cluster right now. I have other clusters that get spun up and spun down all the time, and only a few in this cluster, but we'll actually be looking at the entire environment. So here on ESXi 06, you'll actually see I've got gobs of virtual machines, and most of them have vGPUs. Something to note with that is vGPUs don't use vGPU resources unless the VM's running. So my VM may only support 4 hosts running on it at any given time. I can still have 8 or 16 or any number of powered off VMs with vGPUs. So with that, I'm going to log in and we're going to go ahead and get started inside of Visual Studio. So we're going to start out with the very first script in here, which is just connecting to our vCenter. So real straightforward script, and this is going to be the base script for everything else that we do throughout here. You can see I've got a main function here, and basically we're doing a smart connect to my vCenter, and VMworld 21 is my username. VMware 1, I know it's a real original password, my password into the vCenter. And basically we're just going to make sure our connection works and print out all of our host content for that. So from here, all of the new code will actually go in between these two comment sets. So I'm going to expand my terminal window here, and we're going to go ahead and play this. And you'll see here, we've got gobs and gobs of information. And most of that's not going to help us with our GPUs, but we know we're able to connect. So that's the important thing. That said, we want to find out, and this is where the rubber starts meeting the road, what GPUs we have in our host. So again, like I said, between the comment blocks is where the new code's going to be. So in here, we take the connection and we're going to go through and create a view of our host. And this is just looking at host. So that's what this particular view is doing. You'll see here, we do vim.hostSystem. So this is getting us a view of the host in my vSphere environment. So all of those are included in that particular view. And then what we're going to do is go through each host. I'm going to print its name. And then we're going to go through and look to see if there's an instance of the object reference config in the profile. If not, chances are our host is probably powered down. So like 2 and 3 here. And you'll see that here when we go through. And then we make sure to check if it has a shared object or shared pass-through GPU types under the config. And all of this you can find in the mob. If that doesn't exist, it doesn't have a GPU. If it does exist, then guess what? It has a GPU, and we can go in and grab the graphics info array from that location for that host. and we're just going to print that out. And the reason we're doing a for loop on this is because you can have multiple GPUs in a host and they can be of different types and everything. So we want to make sure that we capture the entirety of it. Now, when I say they can be of different types, NVIDIA and VMware will let you have different types of GPUs in a host. You need to follow guidance from your hardware vendor for that. And currently, I don't know of any hardware vendor who actually lets you have multiple different types of GPUs in there. So there's a little disclaimer on that. And then we have all of the else's and exceptions in there. So I'm going to go ahead and expand this real quick so folks can see. And we're going to play. And this is going to go through and look at all of the hosts in the environment. And you'll see here it's going no GPUs found. It found an NVIDIA Tesla P4 on ESXi 07. It says ESXi 02 is powered off, which we can see, and 03 is powered off. And then 06 doesn't have any GPUs in it. So we can see that. We now know that we have a Tesla P4 that we can work with. And that's important so that we know when we're delivering a VM to our users that we're actually delivering them the correct vGPU profile. And yes, you can do this with PowerCLI. I actually have several scripts on my website around doing this with PowerCLI, Martin. So now let's take this a step further and let's find out what vGPU profiles are supported on our host. Again, new content block, and this content's actually going to look really, really familiar. In fact, the only thing that really changes in here is our for loop. This for loop actually goes through and looks at the managed object reference.config shared pass-through GPU types. And so this inside the mob is where we find our vGPU profiles. And it's going to print out the array of vGPU profiles for us. So I'm going to go ahead and expand this again. And this is going to run. And it goes through each host. And here on ESXi 07, that was the one that had vGPU profiles, or had a GPU in it. And we can see our vGPU profiles that are able to be run on that. That may not mean we're licensed for them, but it does mean that the card is capable of supporting those profiles. Now we can take that information and pull that into our scripts, whether we're using VRA or some portal or something, and we can let our AI users select what card what profile, vGPU profile, they need in their virtual machines. So we can start using this to automate that creation and deliver things appropriately to users instead of canning all of this stuff up. So I'm going to shrink this down, and this gets us through the hardware phase of things. Now we're going to go ahead and hop into our VMs with vGPUs. So let's find out what in our environment actually has vGPUs in it. So in here, again, everything is between the new comment lines. And what we're doing here, we're doing this a little bit differently. And this is just for flavor so that you get an idea it can be done this way. We're going through and navigating the environment as opposed to creating a view for the environment. So we're going into a single DC GPU lab, which is indicated by that element 0 there. And we're just going to walk it and get the virtual machines in the data center. And we're going to print out what they are and what device backings and everything that they're using. So I'm going to go through and slide this up a little bit so that you can see this run, and scroll down here, and we'll play this. And this is going to produce an awful lot of virtual machines. So you can see that we have tons and tons of virtual machines. And the one I'm going to play with in the next Python code set is this VMworld 21 or 2021. And you'll notice that in here, it does have a vGPU in it, and we'll be working with that. Okay, cool. So I'm going to shrink this back down, and it's good to be able to know what's going on in your environment, both before you create a virtual machine and after you create a virtual machine. So you have a idea what those VMs are and that it did actually create successfully. So you can start using this as a search mechanism to find it. Oh, and I did forget to mention here on the for loop that actually printed out the virtual machine material, the if statement in here is actually the important part. So isn't in instance, and it looks for a virtual device, which is what we're passing in from our for loop, and the Vim virtual PCI pass-through. That's the first part of the requirement. There's also an additional requirement that it has the attribute Vim virt device backing vGPU, because you can have different virtual devices. So you definitely got to keep tabs on what you're calling there. So with that, I'm going to go ahead and I'm going to add a virtual GPU to a VM. And we'll do that with this set of code snippet here. And this one's going to look different than what we had before. So we're going to go through and we're going to create a new view. This one's going to be a Vim virtual machine. And we're going to go through our list of virtual machines and find VMworld 2021, which is the one I have highlighted over here. And that's going to find that virtual machine. Then we have a quick safety trigger in here to make sure that it found the virtual machine. If not, it's not going to add a vGPU to it. We then create a virtual device config spec, and we're going to be using this here in a few moments when we actually go through and create a VM for AI. We take our config spec, we're going to tell it we're doing an add operation. We're adding a virtual PCI pass-through device, and then we put in all of the descriptions and stuff. And this is information we got earlier when we were looking at our virtual machines. So we're putting that information in right now. And here on this last CSpec line, you'll see that we're doing a grid P4 4Q profile. So that's where the profile really comes into play. And then we're going to fire off a reconfiguration. So just to show this to you, I'm going to edit settings on our VM here. And you'll see that it has one vGPU currently, P4 4Q. I'm then going to come in here. And we're going to go ahead and run this. And you're going to see that it's going to do a reconfiguration here, and momentarily in the recent task, reconfigure virtual machine. and we get a message that it worked with the virtual machine here. And if I come in again and edit settings, and the joys of a live environment, you'll now see that we have two vGPUs, device 0 and device 1. So we can have up to 4 vGPUs per host. Now, there's a gotcha on this in that you can put like I said, up to 4 vGPUs in there. Those vGPUs all need to be using the same profile. So in this example, they would all need to be using a P4 4Q profile, and they all have to consume the entirety of the GPU. So in my case, I couldn't actually power this VM on because it only consumes half the GPU, and it has to consume the whole GPU to be able to have multiple vGPUs in the virtual machine. So little caveat there that it will let you create it, but it won't actually let you power on. So something important to know there. And I could run this several more times and add more vGPUs to that VM, but in the interest of time, I'm not going to. We're going to actually remove that. We're going to do some cleanup on there just to be good citizens and show you how it's done. So again, we start out by finding finding our virtual machine. And again, we're going to go through, find our VM, safety check to make sure that it actually exists. Then we look to see if it has a vGPU in it. Again, another safety check. And we look for our PCI pass-through instance, and we look for specific types and everything. We grab that as a vGPU object, essentially, and then we're going to use that as part of our spec environment. And that's going to be a config spec again. And we're going to do a remove process this time. And we just pass it the GPU object that we found up here. And it will remove the GPU for us. So when I run this, you'll see another reconfigure task run through and a message saying it was removed. It's important to note that the way this is structured, this is going to remove the last vGPU that it finds. So it's going to pull out PCI 1 vGPU as opposed to PCI 0. If you want it to pull PCI 0, you'll need to modify the script ever so slightly. So that takes us through removing. Last thing we have to do now is to tie all of this together into creating a vGPU or a VM for AI. And I'm not going to install an OS or anything, mainly because the AI admins I know get really, really upset when you say, hey, I'm gonna put this on for you. It's gonna be Ubuntu or this or that. They get upset. So this is actually a script or a Python script from the pyVmomi community. It's out there, the links to it in my blog post and everywhere else in the slide deck and stuff. And it goes through and creates a virtual machine. We made one change to this. So the one change we did was we put our code in here from adding a vGPU to a virtual machine here at the bottom after we've defined everything else for the VM. And that's going to add a vGPU for us. So to run this, I actually use a bash shell script as opposed to running it through Perl, just because it's easier to do that way. So that's a add VM script, and it basically has the name and everything of the virtual machine, how many processors and stuff you want. And we're going to run that. And you'll see that we now have a VMworld new VM right here. And I can edit settings on it. And when it pops up, you'll see that it has a vGPU card in it, ready for us to use. That's how you create a card or a VM with vGPUs in it for an AI user. After that, you fire off your codes to install the OS, your drivers, and everything else that you need for that particular AI workload. So that gets you through all of those processes. And that said, it's time to wrap things up, and I've gone over just a couple of moments. So where to next? Alistair's blog has an absolutely wonderful walkthrough of using the create VM commands from the pyVmomi community. So I'd recommend reading that. You install the OSs, install packages. I recommend turning on SSH if you're doing stuff with NVIDIA cards and you're not doing VDI, just because you lose your display when you turn on vGPU functionality, and then install your AI ML or DL package. If you're doing this in your home lab, I recommend the NVIDIA Container Toolkit. It's real quick to set up. It's a Docker pull with a bunch of automated scripts. Boom, and away you go. Like I said, all of this material is up on GitHub, wondernerd/VMworld21. So you can go grab all of this code from there. It's also available off my website, wondernerd.net. A lot of great material out there. If you really want to get into AI and ML and HPC virtualization programming, check out the HPC toolkit. So with that, here are some sessions you don't want to miss. Most of them have already happened. Some of them have not yet. The one that you really want to catch, if you haven't seen it yet, is VI 2222 got GPUs. Absolutely wonderful session. So highly recommend that one. Lastly, please remember to take your survey for this session. It helps us improve and improve our content and stuff for you as well. Thank you all so much for attending. I'm now going to go ahead and open it up for questions, because I saw a lot go through on chat that I wasn't able to answer. All right, give me just a second here, and I'm gonna stop sharing and just put my face up here on the screen so I can see everything. Okay. And we'll scroll up here to the licenses. Okay. And the driver must correspond, Kenny, yes, the driver must correspond to the correct ESXi version running on the host. So you can't use a 6.5 driver on a 7.0 host, for example. It just won't work. There is some backwards compatibility in the drivers now, but it's definitely not something you want to do for an extended period of time. We talked about this being available on PowerCLI as well. I have a script set out there called VDI by day, compute by night, that uses many of these same approaches to manage virtual machines. Doesn't necessarily add VMs to it, but that would be an easy addition to it. on the opposite. If it can be done in vCenter GUI, then you can code it, code capture for the Power CLI output. Most definitely, Antonio. The 2Q is 2 gigs of video RAM in Quadro mode. Yes, it is, Kenny, and it can be a very expensive license. And the licensing changes depending on which version of vGPU that you're using. Okay. And yes, there are tons of community samples. We'll change settings for the optimizer, would then allow the GPU for Windows and Adobe. Kenneth, if you're still on, I'm not sure I follow your question. Drivers install. Graham, the older K1 cards are not supported, especially for AI. So essentially M series forward, you can do AI with because they have the CUDA cores in them. The K series, really anything behind the M series does not have CUDA in it. And the M series, the CUDA cores aren't really optimal in most GPUs supported in vSphere. So you probably want something in the Pascal series of GPUs. All righty. And virtual PC license and T4 card equaled out to about $65 per user with, yep. Awesome. So, oh, there we go. Would that change the settings you would use on a VDI workstation? Optimizer by default will disable hardware acceleration. Yes, it will change the settings that you use in VDI. There are a bunch of things that flow around that with VDI, where you have to make a bunch of changes to optimize it. And there's some stuff that we're working on around VDI by day, compute by night, that deals with making those adjustments and everything else. And that's more than just a community version of VDI by day, compute by night. And yes, one of those is hardware acceleration and how you're using it. Chances are you would actually switch from a Q profile to a C profile for your AI workloads. And so you'd want to position workloads accordingly on that. And if you have questions, by all means, feel free to come off mute and ask. And awesome. I'm not seeing any more questions. I'm not seeing anyone come off mute. So I think we're going to go ahead and wrap up the session. Thank you, everybody, so much for. Oh, Purple Cape's here, Steve. It's here. I've been wearing the cape the whole time. Thank you, everybody, for joining this code session. I hope you have a wonderful rest of your VMworld experience. Yes, the cape's here. Just for those curious, it is here. So, yes, indeed.